Okay, so we will start today's lecture. So in last lecture we saw the different, uh, particularly the measurement of CO2 gas that we saw through this particular method by measuring the thermal conductivity of the gas. So as we know, the content of the flue gases, we have to first of all measure the content of the flue gases. Then we will understand which method we have to apply or which particular pollutant we have to reduce. Now, this analysis of the flue gases doesn't only give us the idea regarding the solution, but also it will give you the idea regarding the combustion process. Means how efficiently that combustion process has been happened. Or we can say this particular flue gases analysis, if you measure the content of oxygen in the flue gases, it will indicate the how efficiently that particular combustion has taken place inside the furnace. If the amount of oxygen present or the percentage of oxygen present in the flue gas is very high, means what we are providing excess air. So in that case, we can reduce that excess air by using the measurement from the flue gases. Similarly, if the amount of CO, carbon monoxide, is high in the flue gases, in that case, we can understand that, or we can draw the conclusion that the amount of oxygen required for the particular combustion process is less. So in that case, we can increase the supply air to that particular combustion or to the furnace. So likewise, we can also find out the how efficiently that particular combustion process takes place inside the furnace by analyzing the flue gases. Now we know previously mostly we are measuring the different pollutant gases like the carbon dioxide, carbon monoxide, unburned carbon, nitrogen oxide, etc. So by using if you know the gas analyzer, by using the gas analyzer, even whenever we go for any pollution control test. In that case also we mostly measure the content of CO2 than the again the content of carbon monoxide and also the content of unburned hydrocarbons. So by using or by analyzing that particular flue gases, we can find out the level of flue gases inside amount of level of pollutants inside the flue gases, and based upon that we can uh, take different measures to reduce those pollutants. Similarly, the content of or the percentage of oxygen present inside the flue gases, this measurement is also important because it will give you idea regarding the combustion process. Okay, so this this analysis or the measurement of the oxygen from the flue gases, we can use the different methods. The one of the most popular method in this particular case is magnetic wind method to measuring the oxygen in the flue gases. Okay, now we are going to study the magnetic wind method, how it will work, and what are the circuits or the instruments for this particular magnetic wind method. Okay, so as we know, the OT is the more reliable, percentage of OT is more reliable, and the fundamental guide to find out the percentage of excess air we are providing to the combustion. It will totally gives you the idea regarding the combustion, how efficiently that combustion is carried out. Okay, sometimes what will happen, the air which is provided to the combustion, that amount of air will be amount of air is less. In that case, what we are going to do, we are going to increase this particular amount of air. If the O2 content present in the flue gases is very high, in that case, we will know we are providing some excess air. Okay. So in that case, to control over the combustion process, we can use this particular O2 content, or by measuring the O2 content, we can find out how efficiently this combustion has been taken place. Okay. Now for this, we are using many equipments to directly measure the O2. The most important that magnetic ring method that we are going to see here. So first of all, before going for the actual instruments, we should know what are the properties of particular flue gases. Okay. Now, generally, any flue gases which is coming out from the furnace contain mixture of the different gases, right? It will contain the unburned hydrocarbons. It will contain carbon dioxide, carbon monoxide, oxides of the nitrogen. Then the oxygen will be there, nitrogen will be there, etc. So from that only we have to calculate or measure the oxygen content. Okay, just just a minute. Okay. So from the mixture of gases, we have to only find out or we have to only measure the content of the oxygen. Okay. And for that, we are going to using this particular method, magnetic wind method. Now, before that, what are the different properties? How to uh, separate out that oxygen gas from the mixture of the gases? Okay. For that, we are using the properties of the gases. If you know the most of the gases flue gases which is included inside the flue gases, those are the diamagnetic. Diamagnetic means what? It will repulse when we apply the magnetic field around them. Okay. Now, particularly oxygen and the nitric oxide, okay, or the oxide which is based upon the nitrogen, those are the not diamagnetic, those are the paramagnetic. Paramagnetic means what? Now, first of all, understand the difference between diamagnetic gases and the paramagnetic gases. Diamagnetic gases means what? If there is any magnetic field applied, then those gases will be repelled from the magnetic field. Okay, those are called as a diamagnetic. Those are not going to attract towards the magnetic field. It will be repelled from the magnetic field. Whereas the paramagnetic gases means what? Or the paramagnetic property means what? In whenever we apply strong magnetic field, in that case, those gases will attracted towards the magnetic field. Those gases are known as the paramagnetic gases. Now, if you saw most of the gases which are present inside the flue gases, those are diamagnetic in nature except oxygen and the nitric oxide. Those two gases or the nitrogen oxide, those two gases are paramagnetic in nature. So by using this particular property, we can separate out oxygen from the flue gases, and after that we can measure the content of the oxygen. Because if you directly going to measure the oxygen content, we doesn't get the separate oxygen measurement of the oxygen content, because flue gases is a mixture of different types of the gases. Okay, so for that, first of all, we will separate out the oxygen from the flue gases, and then we are going to measure that content of the oxygen from that particular flue gases. Okay, now from the differentiate between the nitric oxide and the oxygen also, as we saw, nitrous oxide is weakly paramagnetic. Now, weakly paramagnetic and strongly paramagnetic means what? If you apply the magnetic field uh, near to that particular gas flow, in that case, the attraction of the nitric oxide, it will less attracted by the magnetic field, whereas oxygen will be strongly attracted toward the magnetic field. Now, these differentiate or the difference between the nitric oxide and the oxygen, we will using this particular property to separate out again oxygen from this nitric oxide. Now, so for that, what we are going to do, we are going to apply the magnetic field. Okay, then whenever the flue gases will be passes near from the magnetic field, in that case, oxygen will be attracted toward the magnetic field. It will separate out. Now, when that oxygen will be attracted toward this particular magnetic field, when it coming to the magnetic field, we will increase its temperature. As we increases the temperature, the paramagnetic oxygen will become the diamagnetic. Its property will change. It again, the all those properties, magnetic properties, are also depends upon the temperature of the gas. So if we increases the temperature, the oxygen will become the diamagnetic in nature, and because of that, what will happen? It will again it will repel from this particular magnetic field. So we are using this particular property of the oxygen because physically we cannot separate out this oxygen by using any physical instruments or anything else. For that, we are using this property, and by using the magnetic field, we can separate out oxygen from the flue gases. Now, this was the one of the oxygen measurement device where we measure the oxygen content in the flue gases. Now you will see this is the annular section. Okay. First of all, what will happen? The gas will be enter from one side of the annular section and it will come out from the other side. Okay. And these two parts or these two sides will be joined by one particular bridge. Now what will happen? We will put up the windings over this middle section. Okay, it will connected into the circuit of the Eastern Bridge circuit, one of the Eastern Bridge type of circuits. And here what we do, we are applying the current. Current will be passed through this particular winding, and because of that, magnetic field will be generated. Okay, at the same time, what will happen because of the current falling, this particular the heat will be generated inside this inside this winding. Okay. Now, what will happen? The flue gases will be passing. First of all, enters from this particular side. Okay, it will enter from this particular side. Now, these flue gases will be passed through this annulus area or the annular area. Now, as the magnetic field has been implemented, or we can say they applied on this particular middle section, what will happen when this flue gas is traveling through around this particular annulus area? The oxygen contained, only the oxygen will be attracted toward the magnetic field. Okay, so because of that, what will happen? The oxygen will enter into this middle part and it will start to travel or start to attract it towards the magnetic field. As we passing through this magnetic field, the temperature which is or the heat which is generated by this particular winding because of the high EMF presented or the voltage applied through this wind, it will take the heat up, take that particular heat and it will flow to the exhaust. Okay, and as this oxygen which will taking the heat from this winding or the from this particular circuit, its temperature will increase. As its temperature increases, its properties are going to be changed. Okay, so that particular oxygen will become diamagnetic. Okay, it will change its property from paramagnetic to the diamagnetic because here the temperature is less. as as this oxygen came in contact into this particular winding or the whatever the heat generated due to the winding, its temperature will increases, and because of the increment in the temperature, it will absorb more. It will because of its increase in the temperature, it will become diamagnetic and it will start to repel from this particular magnetic field. As it flows from this particular section, it will absorb some amount of the heat because of the increment in temperature, and it will goes to the outlet. Okay. Now, because of that, what will happen? The temperature of this winding will decreases. Okay, as temperature of this winding decreases, its resistance is also going to be decreases. Okay, so as temperature of this winding decreases, because the heat will be absorbed by the oxygen, its resistance will be decreases, and that will cause the variation of the resistance inside the Western bridge or the unbalance in the Western bridge circuit, and that will be used, that unbalanced uh, uh, resistance, it has been used to measure the quantity of oxygen inside that particular flue gas. Okay, so first of all, try to understand. We are using the diamagnetic and paramagnetic property of the oxygen here. As we increases the temperature, the oxygen gas will become the diamagnetic. From the paramagnetic to the diamagnetic, it will convert its property. First of all, the temperature of this flue gas is less. Okay, when it will enters into this particular circuit or this particular device or the area. First of all, the oxygen having less temperature, because of this magnetic field, it will attracted, and only oxygen will be passed through this particular middle section. As it is passes through this middle section, it will absorb the heat which is generated by this winding, and also because of the addition of the heat, its temperature will increases. The temperature of oxygen gas will increases. Okay, so temperature of oxygen gas will increases, and that will cause the change in the property of the oxygen gas. Okay, it will become paramagnetic, and because of the it will become paramagnetic, the magnetic field which will repel that oxygen, and it will oxygen will travel through this outlet. Now, during that, what will happen? the temperature of this winding, will reduces because the heat which is generated through that particular winding, it has been absorbed by the oxygen gas, right? So as temperature will decreases, its resistance will decreases, and that will cause the unbalance. And that unbalance is used to measure or the indicate the amount of or the quantity of the oxygen inside the flue gases. Okay, so as content of the oxygen will increases into the flue gases, more oxygen will travel through this particular path, and it will absorb more and more heat. And because of that, the temperature of this particular winding will decreases. It will reduces the resistance, and that will cause the more unbalance in the western bridge. As content of the oxygen will reduces, again the gases, oxygen gas flowing through this particular part will reduces. That will cause the temperature decrement. Less temperature will decrease, and it will causes the variation in the resistance. So that's how we are actually going to measure the particular uh, uh, the content of the oxygen into the flue gases. Okay, so that is the regarding the measurement of flue gases by using magnetic wind method. Okay, so this is the method that we saw. First of all, understand the properties clearly of the oxygen, and then this particular instrument. Okay, so these are the two instruments we saw regarding the gas analysis or the flue gas analysis. We particularly see that is first one, measurement of CO2 by thermal conductivity, and second one is magnetic wind method to measure oxygen content inside the flue gases. Now, next, another instrument we use to measure is that measurement of smoke and dust into the flue gases. Okay, so as we know, first of all, generally in previous decades, we not normally concentrate on the amount of dust or the smoke present in the flue gases. Okay, but after the global warming potential and all those effect on the environment, we are mostly concentrate to measure the smoke and the dust which is present inside the flue gases, because the amount of smoke and dust or the smoke and dust are generally affect the human body, as well as it will going to affect the environment in the in the negative point or the negative way. So for that, we have to calculate or the measure the smoke and dust from these flue gases, and then we can apply, or then we can decide to apply any particular method which will reduce the amount of smoke or dust inside the flue gases. Okay, so first instrument, one of the instruments that we use, that is the photo cell type of smoke meter. Okay, generally those smoke meter you generally saw those ones during the PVC test. Okay, pollution PC test, pollution control test, right? Generally the smoke meters are used for CI engines or diesel fuel engines, because in the diesel CI based engine, CI based IC engine will create more smoke and dust into the flue gases. Okay, so first instrument that we are going to saw, that is the protocell type of smoke meter. Here what will happen? It is simple. It's working is the simple. There is one projector and one receiver is there. Okay. Now what will happen? There is a flue gas pipe will there, which is at the middle. On the one side there is a projector, and on the other side there is a receiver. Now when this flue gases will pass through this particular uh, that particular section of the pipe, the projector, what will happen? It will emit the radiation. Okay, it emits the light. It will emit the radiation. Now, if the amount of smoke particles or the dust particles present inside the flue gases is more, in that case, what will happen? Whatever the radiation coming out from the projector or the light coming from the projector, it doesn't passes through this. It does not going to pass through this particular flue gas flow. Okay, and the receiver will receive less and less amount of light or the less and less amount of radiation. If the amount of smoke particle is less, in that case, what will happen? More and more radiation will be received by this receiver. So by by using this projector and the receiver, or the emitter and receiver, they how much amount of light which is projected or the radiated by the projector and the received by the receiver, that amount of light will be measured. If that amount of light measured by the receiver is high, then the smoke or the dust particle contains these flue gases will contain less smoke and dust particle. If the light which is received by the receiver is less in amount, or the radiation which is received by the receiver is less, in that case the amount of smoke or dust particle which are present inside the flue gases will be the less. Okay, so simply that particular radiation and the light projector or the emitter and the receiver uh, assembly, we can find out the amount of smoke and dust particle present inside the flue gases. Now, these particular readings will be continuously recorded into the recorder, any external recorder, and this particular the emission received or the radiation received by the receiver, that amount of radiation will be measured by the different instruments, and that has been recorded for the analysis. Okay, this one is continuously recorded. Okay, now one of the major drawback of this particular instrument is that uh, when continuously these particular flue gases will be flowed throughout this particular pipe, what will happen? Some dust particle or the smoke particle will present or be deposited on the glass cover of this projector or the glass cover of the receiver. So because of that, what will happen? There is a chances of miscalculation or the measurement of this particular emission by the receiver sometimes or by the projector also. Okay, so it is those are the one of the major drawback of this particular smoke meter. Okay, so it is a simple one. The smoke and dust particle, we are mostly using the radiative type of instruments, which will, or we can say the optical type of instruments, to measure the amount of smoke particle or the amount of dust particle. Similarly, there is another another meter is there, which is used to measure the dust particles. Okay, so this one is a simple one. Here we are using the one projector or the emitter is there, one receiver is there. Light will be passed through this particular pipeline or the pipe which is where the flue gases will be flowing, and this light, how much amount of light will be diffracted by this particular smoke particle, which has been measured by using the receiver. Okay, so by using the amount of light received by the receiver, by using that particular lever, we can find out the smoke and dust particles available inside the particular flue gases. Okay, now next meter is, which is the reflected light dust monitor. Now, major problem for this particular smoke meter is that after some time, the glass cover which is present on the projector and the glass cover present on the receiver, it will going to be dull. Some smoke particles or the dust particle will be just deposited on the glass cover, and that will cause a miscalculation or the measurement will be the wrong one. Now, to avoid this particular problem, we can use this reflected light dust particle. Okay. Now, this one is also one of the optical type of measurement device where we use the electric beam. Okay, or the lamp will be there or the reflector will be there. Now that will emit the radiation. Okay, now when it will emit, you can see there is a tube. This one is the tube. Okay, where through which the flue gases are passing or flue gases are traveling. Now on this right hand side, you can see this is the one lamp or reflector is there. Lamp and reflector you can see here, and one photo cell is there. Okay, and these two are been connected to the amplifier and indicator, and also with the recorder. Now here what will happen when flue gases is passing through this particular tube? At the same time, this lamp and reflector will reflect or the emit the radiation. Okay, it will emit the light. Now this light or this radiation will be reflected back from the dust particles. It will incident on the dust particle and it will reflected back by the dust particle, and this reflected radiation will be measured or it will be absorbed by this particular photocell, or it will be measured by this photocell. Okay. Now, by that particular principle, it will measure the amount of radiation reflected from this particular gas, and it will be measured by this particular photocell, and how much amount of radiation which is emitted or reflected by this dust particle, that much of dust will be present inside the flue gases. Okay, so it is totally depends upon the radiation which is measured by the photocell, or it will receive how much radiation is received, or how much light has been received by the photocell. That much dust particles are present inside the particular flue gases. If dust particles are not present, in that case, the amount of radiation reflected from the dust particle will be less. The probability is very less. So in that case, the amount of radiation received by the photocell is also going to be less. Okay, so that's how we can use this reflected type of dust monitor to measure the smoke and dust inside the flue gases. Now, the main advantage is that there will be no any chances of that particular dust particle are going to be uh, uh, the dust particle is going to there will be no any dust particle are not going to be deposited on this particular lamp on photocell, because those are not in directly contact with the dust. Whereas in the previous meter, you can see these projector and the receivers are generally directly in contact with the flue gases. Okay, so that is the main advantage of the reflected light dust monitor. Okay, now these particular readings which is coming out from the photocell, it will be continuously going to be recorded. Those signals are going to be amplified, and that signals or those measurements is continuously going to be recorded in the recorder, and that has been used to analyze the flue gases properties, or we can indirectly analyze the combustion process by measuring the smoke and dust. Okay, so that those are the measurement device we saw. That's the end of the measurement device. Okay, uh, from first one, we are going to see first of all, the what are the importance of the measurement and instrumentation in the power plant, that we saw, to find out the performance, or to find out the operating guidance, or the maintenance and repair guidance, for the economical supervision, cost allocation. For all those reasons, we are using the measurement instrumentation in the power plant. There are many types of the instruments are there, in from which we saw the most important instruments. First, that is the measurement of water purity. With the water, feed water used in boiler, how much pure is that particular water? For that, we are using the water pure. We are going to measure the water purity by using the different method. One of the method we saw, that is using the thermal conductivity or electrical conductivity of that particular water, feed water. Then the dissolved oxygen also we used to record or to find out the dissolved oxygen by using this particular oxygen this particular method, this particular device. Okay, then the measurement of pH value of the water. Okay, for that we are using electrometric method to measure the pH value of the water. Okay, similarly, we also find out study the different measurement device which will use to analyze the flue gases, particularly the flue gases, the measurement of content of CO2 in the flue gases by using thermal conductivity method. Also, we can find out the oxygen content of the flue gases by using a magnetic wind method. Then the smoke and dust which is present inside the flue gases by using photocell type of smoke meter, and by using the reflected light dust monitor. So these are the measurement devices or the instrumentations which are used to find out the quality of water, as well as the amount of the gases which are present inside the flue gases. Okay, because the flue gases are the main polluters. Most of the air pollution, it is because of the flue gases. Most of the pollutant will mixes with atmospheric air through the flue gases. Okay, and it is because of the combustion process. Similarly, for in the case of water purity check, we have to check the water purity, because it will going to affect the efficiency of the power plant. it will going to affect the maintenance schedule and the maintenance cost of the power plant. So these are some of the measurement instruments we saw up to this particular point. Okay. In the next point, we are going to see the different instruments which are used to control the pollution. Now here we measure the amount of pollution present inside the flue gases. Okay. At the next point or the next instrument we have to study, that is the how to control this pollution. Okay, how to control the amount of these gases present inside the flue gases. Okay, so for that we are going to see the different instruments like the catalytic converter. Also, EGR is one of the instruments is there. So likewise, we are going to see the different instruments which are used to control the pollution level. Okay, we first of all measure the pollution level, and then we are going to control the pollution level. Okay, so we will stop here. In the next lecture, we are going to see the this particularly the pollution control device. Okay, or the pollution control instrument. Okay, so we will stop here. If anybody have any doubt, you can ask now. Yes, this the same principle has been used. Okay, there are much similar principle which are used here in the reflected light dust monitor. Okay, spectrometry, right? All those are the optical devices. Okay, where we use some sort of radiation or some sort of light to measure the properties. Okay, that's why you will see that there is a similarity between these optical devices, because the principle is the same. Here we are using reflected property of the particles. Okay, in some case we are using different property. It is depends upon the properties of the gas. Okay, or the physics of that particular gas. Okay, any other doubt or query you can ask now. Already I shared PDF notes regarding the of this particular the three chapters. Okay, I will also share this PPT presentation on the Moodle as well as on the WhatsApp group. And for any other reference, you can use any reference books. Particularly, you can use Dumkunwar, Power Plant Engineering of Dumkunwar, or you can saw the different NPTEL courses on the power plant. Okay, and regarding the assignment, I already shared you the assignments in last, I think, 15 days back. Okay, so complete those assignments and uh, submit those one on Moodle. Okay, there is a tab called as assignment number one, ISC one, component A. Okay, submit your assignments before 31st March. Okay, so that is our first component of ISC one. The second component will be quiz, which is depends upon first three chapters. Okay. Okay. So we will stop here. Okay. The remaining points we will going to cover in the